Yay, calculus. Yay. Alright, 47. 47, we have x squared plus 2y squared equals 9. Alright. So this is an ellipse. So we got both squares and connected by a positive. And we're doing this at point 1, 2. So, get to work our slope. We'll go to our first derivative, which is going to be 2x plus 4y dy dx. Oops. Slope is equal to our first derivative. Let's start that again. Because it's not a y equals equation, so we can just take the first derivative. So that's 2x. We'll find the dy dx in it. Plus 4y dy dx equals 0. And that means that 4y dy dx equals negative 2x. And that dy dx is going to be equal to negative 2x over 4y equals to negative x over 2y. And this is our slope. Now we can write that down there. Evaluate it at 1, 2. So our first derivative evaluated at 1, 2 is going to be negative 1 over 2 times 2, which is negative 1/4. So find our tangent line. Use our slope of negative 1/4. Use our x, which is 1. Use our y, which is 2. Solve out for b. If 2 equals negative 1/4 plus b. And 2 plus 1/4 is going to be 9/4 equal to b. And we'll have y equals negative 1/4 x plus 9/4. That's our tangent line. Another y equals mx plus b. For our normal line, we're going to keep our 2. We're going to keep our 1. Our slope is going to change though. Instead of negative 1/4, it's going to be 4. 4 being the opposite reciprocal of negative 1/4. So we'll subtract 2 on both sides, or subtract 4 on both sides to get b. That means that our slope of our normal line will be y equals 4x minus 2. Is x plus the square root of xy equals 6. I'm going to graph it in my calculator using parametric equation solving out a fraction y, but as is we don't need to. We do need to find a point at which we want our tangency to be and our normalcy. So at 4, 1. So here we go differentiating. Straight across 1 plus all this to the 1/2. Let's see. How do we want to do this? We can do this as chain rule, product rule. Or we could do it as x to the 1/2, y to the 1/2. Kind of like that idea. But we'll do it both ways. So do this one over here. So we'll do this as power chain rule. It'll be 1 plus 1/2 xy negative 1/2 times the derivative of the inside, which is going to be product rule. Product rule on xy is going to be derivative of the first, which is 1 times the second, plus derivative of the second times the first. It's all equal to 0. That's one way to do it. See if the other way is easier. We change this to x plus x to 1/2, y to the 1/2 equals 6. take the derivative now. 1 plus, that is product rule. So the first times the derivative of the second. 1 half y to the negative 1 half dy dx plus, see, first derivative of the second, second derivative of the first, is one of them easier than the other? I'd say that one's easier. So we'll go with the easier way rather than the harder way. I was hoping that would turn out better. They're both doable. But simplicity is our friend. Alright, so this is multiplied. So we'll need to divide by this, but after we subtract this off, we're going to subtract 1. Let's just do that in one fell swoop here. And then we'll divide both sides by this. So this will be y plus dy dx x equals negative 1 over 1 half x y negative 1 half. This is a negative and this is a fraction. So let's clean that up a little bit before we move the y over and divide by x. So this will be a 2 up top, so it'll be negative 2 xy to 1 half. So we divided by 1 half, we got 2, kept the negative, dividing by 1 over xy to 1 half is xy to 1 half. So now we can subtract y and divide by x. And we'll rewrite this for convenience sake, because we're about to put in 4 and 1 here. And good, we'll have the square root of 4, that'll be nice. So let's see, so that was the top, we subtracted y, and we divided everything by x. Which, of course, we'll then need to evaluate. So dy dx. I'll see down that low? No, you can't. Good. So here's our slope of our tangent line, dy dx, evaluated at 4, 1. Equal to, nice big fraction, negative 2 times the square root of 4 times 1 minus 4 all over 1. So our slope again is going to be 4, 2, negative 2 times 2 is negative 4 minus 4 all divided by 1, which is going to be negative 8. So we've got our slope. I equals mx plus b. Y is 1, m is negative 8, x is 4, b is yet to be determined. So 1 plus 32 will be 33. So the slope of our, or the equation of our tangent line, y equals negative 8x plus 33. We'll do another one. Y, which is still 1, m, which is the opposite reciprocal of 8, which is 1/8, x is equal to 4, plus b, 1 equals 1 half plus b, so 1 half equals b, and y equals 1/8 x plus 1 half is our normal line. And t is going to be 3 pi over 4. Hopefully y'all have done enough of the parametric equations now. Realize we got sine and cosine, which means this will either be an ellipse, a circle, or a hyperbola. And as they're the same sign and they're equal, means it's a circle. So in all likelihood, we're going to get negative x over y, negative cotangent to t, but we'll go through the motions here. We still need to evaluate at this point. So we're going to differentiate this with x with respect to t, differentiate y with respect to t, and then we'll get dy dx by our formula, dy dx, or dy dt over dx dt. So here we go. Differentiating with respect to t. Derivative of sine is cosine. Derivative of y with respect to t. Derivative of cosine is negative sine. And our formula dy dx is equal to dy dt over dx dt. It's easy to remember because they invert multiply, get dy dx. So dy dt is negative 2 sine of t over 2 cosine of t. So we'll evaluate dy dx at t equals 3 pi over 4. This will be our slope of our tangent line. We just need a tangent line, right? Yeah, good. Alright, so here we are. So that'll be negative 2 sine of 3 pi over 4 over 2 cosine of 3 pi over 4. Alright, so unit circle, starting at 0, pi over 2, 3 pi over 4. That means cosine will be negative, sine will be positive because we're in the second quadrant. It'll be negative 2. Sine of 3 pi over 4 is radical 2 over 2. Cosine of 3 pi over 4 is going to be negative radical 2 over 2. It looks like these are the exact same thing. 2, 2, radical 2 over 2, radical 2 over 2, negative, negative. So happy day, it looks like 1, which makes sense. Were this a circle of, I guess, radius 2, we're talking about point up here, our slope would be that. That does make sense. We could have done that logically. But it's all good. Where it hits our y-axis for our b value, that would be nice to know. Y equals mx plus x plus b. We evaluate y as such? No. So y at 3 pi over 4, cosine of 3 pi over 4 is radical 2 over 2, times 2 is just radical 2 over 2, or cosine of negative. I'll write that out. So y equals 2 times negative radical 2 over 2, which is just equal to negative radical 2. Negative radical 2 equals m, the slope is 1, x, sine of 3 pi over 4 is radical 2 over 2, times 2 is just radical 2. B, we'll subtract radical 2 from both sides. Wind up with y equals our slope, which was 1, x minus 2 radical 2. Doesn't make sense, does it? With negative radical 2 over 2, and positive up there. What did I do wrong? What indeed? I have y and x backwards. No, x was sine, y was cosine. That's unusual. What would be that? Oh, you know what it is? The sine, cosine are backwards. So when t equals 3 pi over 4, we are at x equals radical 2 and y equals negative radical 2. So we're actually down here. So probably a good thing we didn't do that logically, because we're not up there. I was thinking that y was equal to sine, x equals cosine, so often is the case. So this is in fact correct. Even down here, that's just that we're a kilter.